This lesson is about solving linear equations. But before we start talking about what that means and how to do it, we need to learn about like terms and bringing them together. Like terms are terms that contain exactly the same variables raised to exactly the same exponents. The only thing that could differ between these like terms is the number in front, which is called the coefficient. So, number one, we're going to simplify the expression by combining like terms. These terms are all alike because the x's are raised to the first power. And we all know that the first power isn't there because math people are lazy and they don't want to write it in because everybody knows it's to the first power. So what we're going to do is we're going to think about this as 3 pieces of paper with x written on it. The 3 is called the coefficient, the number in front, coefficient. X is the variable and the exponent is, of course, 1. So think about it as 3 pieces of paper with x written on it. Take away 2 pieces of paper with x written on it. You get 1 piece of paper with x written on it. And then we need to add 7 x's, 7 pieces of paper with x written on it. So we get 8x. Good? So that is our combined value here. Now what we're going to do is we're going to do some distribution and combine like terms. Here we go. So first we're going to distribute the 2 through. 2 times 3 is 6x. So I've really doubled the number of pieces of paper with x written on it. I double 11 and I get 22. Now that's where the distribution ends. It ends with that shut off parentheses and everything else stays the same and gets written down. So now we're going to combine the like terms. So the x's are alike, 6 of them, take away 7 of them. And this is how I do it. I always take the sign right in front and think money. I have 6 x's, but I owe you 7. So I still owe you 1x. And now I'm going to combine what we call the constants. Those are numbers that are just hanging out with no variables. So I have $22, I have another $12, so I have a total of $34. Now you can write it like this, or the sophisticated math people of the world will write it like this without the 1 in front. It'll look like that. And those two cannot be combined because they are not alike. 34 doesn't have an x attached to it. So, wah, wah, wah. We can't do anything else with it. We're done. Now let's do the next one. So, here we go. First, we have to distribute. So, we're going to distribute the -3. So, we have to keep in mind our rules for multiplying negative and positive numbers. Write down the ones that don't deal with that. -3 times x is a -3x. -3 times a -12, think of those as negatives, is a positive 36. So now we're going to combine like terms. Now there's a single x here, but that really means 1x. So I have an x, but I owe you 3 of them. So I still owe you 2 x's. And the 8, I have $8, I have $36, so I have a total of $44. And -2x and 44 can't be combined, so we leave it. Now we're going to do the big blowout of starting to solve a linear equation in one variable. That's an equation of the form ax plus b is equal to c. There's no squareds in it. There's no cubes in it, okay? B and C and A are constants, okay? And A can't be 0, all right? So this equation is linear. X take away 3 equals 10 is linear, but this one is non-linear because it has a squared in it, okay? So now there are several properties for equations. But the thing that you need to keep in mind is that an equation is a balanced scale. When I have an equal to, that's my balanced scale. And when I'm presented with an equation, both sides are balanced. And we need to keep it that way. What I add to one side, I have to add to the other to keep it balanced. What I multiply on one side by one thing, I have to multiply on the other to keep it balanced. Same thing with division and subtraction. So keeping these two properties in mind, the addition property of equality, that just says you got to add the same thing to both sides or you're not going to stay balanced. And the multiplication property of equality says you got to multiply by the same thing on both sides or you're not going to be balanced. You just have to be careful about zero. Zero's off limits, okay? Totally off limits. You just can't use it. It's got to be any other number but zero, okay? With multiplication. All right, with addition, you can add zero. It's not going to matter. All right, keeping these properties in mind, these are the steps for solving equations. We're going to distribute, combine like terms, move all the variable terms on one side by adding or subtracting. Move all the constants on the other. What's a constant? That's a number without a variable. Make sure you get a coefficient of 1 in front of the variable by multiplying or dividing. Check your result for reasonableness. Okay, so now we start off slow and then we get intense. So here we go. This says x minus 3 equals 10. So I need to get the minus 3 off of both sides. So I'm going to add 3 to both sides here. Because what happens here? The x comes down. I owe you $3, but I give it to you, so my debt is wiped out, and 10 plus 3 is 13. Let's do the check. Yeah, let's. X take away 3 is equal to 10. So I'm totally putting 13 in for x. Does it check? Yepper doodles. Now, you guys, a lot of times these things, you can look at it and check it, but the more intense ones, I feel I need to check sometimes. So we'll see how it goes. Now, this next one, the first thing that we usually do is distribute, but there's no distribution here. Then combine like terms. Oh, there's like terms. I have 3y's. I take away 2y's. Remember, this is a side. 3y take away 2y is a 1y. So y is equal to 11, and I'm done. That one you don't need to do anything else. There's no adding to get the variable alone. The coefficient in front of the y is 1, so we're all psyched. Everything is fabulous. In fact, if I do the check, 3 times 11 minus 2 times 11 equals 11. Yeah, 33, take away 22. We're good. We're totally good. Next. Okay, this one we need to do a little bit of distribution first. So I'm going to distribute, voomp, voomp. So I get 5x plus 1 is equal to 4x, take away 8. Good, because 4 times x is 4x, 4 times 2 is 8, but I have the negative in between. Now I have variables on both sides, so I got to move it to one side. I'm going to do that by taking away the 4x. Good? See, that's my side. When I jump sides, I have to do some kind of opposite operation. So these will cancel out, and I have a negative 8 on this side. 5x take away 4x is just a plain old 1x or x plus 1 equals negative 8. Now we got to get rid of that 1. How do I do it? Well, the opposite operation to addition is subtraction. I got to get rid of it. So x is equal to, I owe you 8, I owe you 1, I owe you $9. Now, does it check? Oh, absolutely, because we are so good. I always write down my original equation. and 5 times my answer that I perceive as correct is negative 9. Okay, 5 times negative 9 is a negative 45 plus 1. Now, in here, I don't have to do the distribution. I can just do that operation. I owe you 9, I owe you 2. You better believe I owe you 11. And now this side becomes, I'm sorry, the left-hand side becomes a negative 44. Negative 44. I am golden. Good. So done. My answer is x is equal to negative 9. And I've shown that it did indeed check. Now let's do the next one. Yeah, let's. So for D, again, I have my fence there. I need to jump the fence to get the variables together. And for this one, I'm going to add 6x to both sides. And the reason why I did that, you don't have to, you can add 2x, but I like to get rid of my negatives if possible. So the negative 6x and a positive 6x will add out, and I get 18 is equal to 14 plus 4x. And again, I have that barrier, that 14 needs to go, because I got to get all the variables on one side, all the constants on the other. So I owe you, I'm going to subtract 14 from both sides. I'm always thinking owe and give, and so I have 18, but I spend 14, so I have $4 in my pocket. So 4 is equal to 4x. Now, this is the first time we've seen a number in front of the x. That means 4 times x. I want to get rid of it. So the opposite operation is division or multiplying by the reciprocal, right? So I will get 1x is equal to 1. So x is equal to 1 on that problem. So I'm psyched. Okay, now these two problems are the, like the powerlifting problems. It's like when you're exercising, you need, to keep your intensity up. This is it. So what we're going to do first is look for a distribution. There is none. Then, keeping in mind my sides, combine like terms on a side. This one we have to. These are all on the same side, so I have to combine them before I start moving things. It's easier. You don't have to, but it's easier. So you get 5x plus 8 is equal to negative 7 plus x plus 11. Okay, I have like terms on the right-hand side as well. So I'm going to combine those. I owe you $7, and I have $11. So I really have $4. Now you're like, well, how come you're not changing signs? Because I'm not jumping the side. Okay, I'm not moving it across the equal sign. So now here's the next one. I am going to get the x over to the other side. See, now I'm jumping sides, so I'm doing the opposite operation. So 5 take away 1x is 4x plus 8 is equal to 4. I'm going to make that 8 jump over, subtract him off. So I get 4x is equal to negative 4. Now I have the 4 in front of the x. I got to get rid of it. It's under multiplication. I divide both sides by 4. So x is equal to a negative 1. Yay! Okay. And last but not least, we're going to solve this one and check it. So here we go. First thing we're going to do is distribute on both sides. So we're going to get 10x, take away 5, take away 15. 3 times 4 is 12. 3 times 2 is 6. Cool? Combine like terms on a side. Now keep in mind, here's the side. So if you're not moving anything from side to side, you need to combine if they have like terms. And I owe you 5 and I owe you 15. So I owe you 20. And on the other side, again, the 6 and the 4 are like, so we're going to combine them. Good. Now we need to move stuff. Now look at, I have a 12x and a 10x, so I'm going to move the 10x. How am I moving it? I'm subtracting it. Okay, but you say, well, over here you divided. Yes, because I needed to keep that x on that side, so I had to break the 4 away from the x, and they were connected by multiplication. So I used division. But here, I need to get rid of the whole thing, so I need to subtract it so it will add out. 12x take away 10x is 2x. And I'm going to subtract 10. So I'll get 2x is equal to negative 30. So over here, I'll have negative 30 is equal to 2x. Again, I need to get a 1 in front of the x. I'm going to divide by 2. So x is equal to negative 15. Cool? So now we can do the assignment associated with combining like terms and solving linear equations. Again, ask your instructors if you have any questions. Good luck and have fun.